Good afternoon, and it's a privilege to be here and in Institut Pasteur as a physicist. It's a bit strange. And it's a privilege to be here to honor the new generation of PhD graduates. I would like to express how much it's both a privilege and a responsibility to be part of the few people on Earth who have been trained by research and therefore have the duty of being ambassadors of science, whatever your future career choices will be. My presentation, I hope it can start. So my presentation is really focused on the transformation challenges related to a changing climate. And this is an attempt to convey our findings in a clear way, in a human way. So what you see is a stripe diagram going from blue to red, showing changes in global surface temperature, one indicator of the state of climate, observed warming to date. And then we look at possible futures, which are the outcomes of climate projections, depending on choices in terms of greenhouse gas emissions, very high, intermediate, low or very low emissions, have different implications for future living conditions. And we have added people at different ages to illustrate how much these choices matter for the living conditions of the aging ones and for the living conditions of today's young generations all over this century. What I would like to stress with this visual is I started my own PhD thesis 30 years ago. At that time, I was motivated by curiosity-driven research. At that time, it was, observing the Earth from space, being able to reconstruct past climates, the start of ocean atmosphere climate modeling. It was exciting, to be able to join that. And when I had the privilege of accessing the peer-reviewed literature, which was not possible as a student, only when you were part of an institution, I remember the vertigo that I had when I realized at that time already the magnitude of human influence on climate. And 30 years after, what is really striking is that what is unfolding now had been anticipated properly by the first climate projections. In 2021, the Nobel Physics Prize was jointly attributed to Suki Manabe, a Japanese-US scientist who was a pioneer in climate modeling. And his first publications in the 1980s had properly anticipated, the response of the climate system to greenhouse gas emissions. That's also the power of physics. And 30 years after that, instead of anticipating impacts that would affect future generations, we see it widespread everywhere. We see the limits of our response strategies, even in the wealthiest countries, being challenged by extreme events. And at the same time, we have such a better understanding of what can be done, what are the solutions that can be deployed and could allow us to shift from an intermediate situation where current policies at play have already avoided emissions of billions of tons of greenhouse gases. So we've already made very high emission scenarios much less plausible. But we also have the resources to reduce emissions sharply while ensuring the needs for sustainability and development everywhere, and shift again towards lower emission trajectories. What you also see is with an intermediate projection, we expect to reach a level of global warming of 1.5 degrees above pre-industrial globally in the next decade. We expect to exceed 2 degrees of global warming by 2050. This means a failure of respecting the goals of the Paris Agreement. So we're not there yet. And the challenge is now bigger because we have both to adapt to a changing climate that will be unavoidable. We have to support those most vulnerable with increases in losses and damages, and we have to reduce emissions in a more stringent way because we have not done it at the right scale before. And I want to highlight 2050, because for the youngest ones who are here, by 2050 you'll be my age. And I can tell you a professional life goes very fast when you have the chance of doing a job that you like. So thinking now of where you might be in 2050, what will be your legacy in terms of practice, in terms of science advances, it's really the right time to do it now. So the presentation is grounded in an assessment of the state of knowledge, which has been, for me, one of the greatest joys in my scientific career. It has been working with hundreds of scientists from around the world, looking at the evidence from the literature with a critical mind, so as to be able to distillate what is the state of knowledge, what is robust, confirmed, what is novel and still needs to be verified and confirmed, what are the remaining knowledge gaps, which in fact are really stimulating for young scientists, because that's where you need knowledge advances to address those gaps. So since 2015 until last summer, we have been working together to provide to decision makers the best state of knowledge. And the IPCC process is quite unique, and it's a co-design process. We listen to the needs expressed by the delegates from all governments. We do our work, we distillate the key findings with multiple review steps, that scientific rigor, which is critical. And at the end, the summary for decision makers are approved word by word by the delegates of all countries. And that very heavy, time-consuming process makes the reports extremely rigorous, and at the same time, it allows to generate a body of knowledge recognized by all countries. It's really the value of science, and even if it can be disturbing compared to your own geopolitical interests, you recognize it as a state of knowledge and a common basis, for instance, for climate negotiations taking place currently at COP28 in Dubai. And I summarize this massive amount of knowledge. A main working group report is 3,000 pages. Nobody reads it. There's a special chapter on health in the Working Group 2 report on impacts and risks, which might be more relevant. And if you want to interrogate these reports in an interactive way, a French company has developed an artificial intelligence tool, a sort of ChatGPT, called Climate Q&A, and you can go through this mass of reports, formulate a common wording question, and have the sources in the report with the relevant keywords so as to make it more accessible. So this feeds a 30-page synthesis, which I summarize in 3 words: the seriousness of the current situation, that will be the first part of the presentation, then the urgency to change scale, considering possible futures and futures that are going to be very hard to manage. And the last point is the capacity to act, how to change scale, and what are key dimensions that need to be implemented to limit the escalation of climate-related risks. So let's start by where we are now. And I've stressed the transformation challenges, and I think it's really powerful to look at what action has already been implemented, to look at ourselves as actors of transformations. So we see a decoupling between economical growth and greenhouse gas emissions in more than 20 countries. We see that public policies, in particular related to innovation policies, efficiency, have allowed to avoid several billion tons of global greenhouse gas emissions per year since around 2015. More than half of emissions are in the scope of public policies, with a growing numbers of regulations and laws. We see advances in technologies such as low-cost production of renewable electricity, batteries that can decarbonize transportation, decrease in costs, increases in capacity installed. We also see a slow progress in adaptation through planning and implementation, but, and it's particularly the case for health, a gap between the scope of adaptation actions and what would be needed to avoid today's risks, and a lack of transformative adaptation where you build on knowledge on future risks so that you create more resilience, accounting for what will change in the future as well. We also see evidence of maladaptation, where in urgency, one solution is implemented that can have inequity effects or unintended consequences, and it can be also a health concern. Altogether, what is also striking is the lack of financial flows to support emission reductions and adaptation, in particular in developing countries. And that's one of the hard points taking place currently in Dubai in COP28, in particular related to the global adaptation goal. So altogether, the pace and scale of where we are now is not yet sufficient to limit the escalation of climate-related risks. And it is illustrated when you look at global greenhouse gas emissions. With COP28 in Dubai and perceived obvious conflicts of interest related to the exploitation of fossil fuels in the host country, you cannot skip a focus on the role of fossil fuels. You can see the emissions of CO2 from fossil fuels and industry, mostly cement production here. It's the major driver of the increased accumulation of heat in the climate system. And you can also see an update on the right, where you have the slow decrease during the pandemic, the lockdown effect, and then the rebound. The latest estimates published this week by the Global Carbon Project still show a slow increase in fossil fuel emissions until now. So we have not yet reached the time when a peak is reached and a decline is started. It could be soon, but it's not there yet. You can also see a rather stable emissions of CO2 from land use changes, mostly deforestation or afforestation, with contrasted situations in different countries. And the rest of the other greenhouse gas emissions are in particular related to methane and nitrous oxide, in particular emitted from agricultural activities, livestock, and the use of fertilizers for food production. The food system as a whole accounts for about a third of global greenhouse gas emissions. And historical and ongoing contributions are unequal. One figure I find striking is the following. 10% of people in the world, most wealthy ones, account for about 40% of emissions, with a capacity to act. Half of the world's population, often deprived of basic services for health, education, energy, account for only 15% of global greenhouse gas emissions, with the key challenge of allowing faster access to these basic services and clean technologies so that it can be achieved without a growing use of fossil fuels worldwide. So we add greenhouse gases in the atmosphere. The level of CO2 now is unprecedented in millions of years. And this leads to an accumulation of heat in the climate system, also shaped by the feedbacks of the climate itself. That's the beauty of climate science, its complexity. This visual just is intended to show where does this excess energy go. So 1% of the excess energy is warming the atmosphere, lower layers where we live and breathe. 5% is warming the soils over lands. It's changing the growing season for plants. It's affecting the biosphere. 3% is converted into the melt of snow and ice. So a shrinking of the snow cover, a melting of glaciers that is unprecedented in more than 2,000 years. Just in the Alps, the remaining glaciers lost 10% of their volume in the last 2 years. A shrinking of the Arctic sea ice, a shrinking of the Greenland ice sheet, a faster flow of the Antarctic ice sheet are also consequences of that heating. And most of the excess heat goes in the ocean. So the ocean gives us a tremendous service of storing that heat, limiting warming at the surface. But this service has a cost, and the cost is heating of the ocean, marine heat waves, changes habitats for marine life, and at the same time an expansion of the warming ocean, which, together with the melting land ice, leads to sea level rise. Sea level rise has accelerated since the 1990s, And we have already committed from past emissions, current warming, the slow response of glaciers, ocean circulation over hundreds of years, ice sheet responses to about 1 meter of sea level rise over several centuries. And this will happen earlier with emissions to come now. So we also have to think of our effects as a long-term heritage that will shape the habitability of coastal areas worldwide. When we look at the same indicator I showed at the beginning, you know, the level of global surface temperature change, it's the same figure but in a usual scientific display here. What you can see is that the rate of warming is even faster in the last decade compared to previously. So what we understand is the following. No natural factor accounts for the accumulation of heat in the climate system. Solar activity, volcanic activity, natural climate variability modulates human-driven trends. And when you look at the part of observed warming that is attributed to human influence, you can see it is equal. Our best estimate is 100% of warming to date is due to human activities. You can even see that more than observed is caused by emissions of greenhouse gases, because it's partly masked by the umbrella or cooling effect of pollution particles. In Europe, North America, and China, public policies to improve air quality for health concerns have been fruitful. So we have reduced the amount of these pollution particles, and as a result, we unmask the warming effect of greenhouse gases. So the two factors in the last decade have played in the same direction, so a faster warming rate. And compared to the IPCC report released a few years ago, we're now trying to provide an annual update. So this is the example from last year. What do we see? Continuous increase in global greenhouse gas emissions, concentrations, effect on the Earth's energy balance, therefore more warming and a shrinking margin of action to limit warming at low levels. A few highlights. This year we have an El Niño event, which is a time when there's a release of heat from the tropical Pacific Ocean to the atmosphere. It's part of natural climate variability, and it adds to the warming trend in the same direction this year. So year 2023, we already know that, will be the hottest on record globally. And we also see now a shrinking of the Antarctic sea ice in the few recent years that was anticipated in climate models, but has only recently been observed and can be the consequence of the accumulation of heat, in particular in the ocean around Antarctica. So it's affecting every region. And it's affecting every region, not just for mean climate, but also for the occurrence and the severity of extreme events, those that have the highest impact on human activities and ecosystems. Each hexagon is a world region. Med is the Mediterranean area, WCE is Western Europe. I hope you can recognize the world map. The intent of these maps is to show with equal size different regions, in particular, for instance, the small islands. So every region is in purple is where we see an intensification of hot extremes over land. When you have more dots, it's a measure of the confidence we have in the fact that the frequency and intensity is increased due to human influence on global climate. It's widespread for extreme heat. Events at 45 degrees Celsius, 50 degrees Celsius are increasingly recurrent, and such record hot extremes would have been extremely unlikely without human influence on climate. You can see in the middle heavy rainfall events. With 1 more degree in the atmosphere, the air can hold 7% more moisture. It means that storms, tropical storms now, with the same trajectory than a few tens of years ago, if they can be refilled with moisture, can lead to more extreme rainfall amounts than in the past. So the conclusions are very clear for all the areas that appear in green. And you can see in the tropics gray area. The data exist, but sometimes they are not available, or the data exist, but no attribution study has been implemented, which is also a challenge because this concerns some of the most vulnerable areas to changes in extreme rainfall events. And in a warmer climate, you increase the evaporative demand on the atmosphere, which increases evaporation, transpiration, and then transforms a period without rain in a more severe drought compared to previously. So you can see in yellow the areas where we observe an increase in the intensity and frequency of extreme drought. It's in particular the case for areas of Mediterranean climate, Western Europe, many areas in Africa as well. These events are exacerbated by urbanization, which increases runoff from extreme rainfall, and urbanization through the urban heat island exacerbates the effect of extreme heat as well. When you have compound events such as extreme hot and dry conditions, this increases the occurrence of fire-prone weather conditions that can lead to more extreme wildfire events than in the past. Climate justice is key. This figure is an attempt to help understand the challenges that we face. On the horizontal axis, you have the emissions per person in the world, per country. So you have, for instance, at 22 tons per person and per year, the United Arab Emirates, where COP28 takes place, one of the places with the highest emissions per person and per year now. And on the vertical axis, you have an index of vulnerability at the scale of a country. So what is really striking is that half of the world's population, around 3.5 billion people, live in highly vulnerable contexts and has least contributed to human-caused climate change. So differentiated responsibilities, historically or now, and differentiated vulnerabilities, which are a key driver together with exposure and responses of the impacts. I would like to bring to your attention the fact that my own community has now developed fast attribution studies. So after a high-impact extreme weather or climate event, the ability to place a diagnosis. Is this just rare natural variability, or is this an event which has been made more likely, more intense, due to human climate change? How has it interacted with local responses, risk strategies, adaptation strategies, so as to be able to understand the link not with climate variability, but with human-caused climate change. And these tools are increasingly important in the context of a mechanism to address losses and damages, and a mechanism where there will be a financial support to the most vulnerable communities hit by human-caused climate change effects. A few highlights recently: extreme drought in the few recent years in Syria, Iraq, and Iran, leading to a water crisis exacerbated by vulnerabilities driven by conflict and war. Storm Daniel, you may remember last September, which in particular hit Libya very hard. There's a human-driven factor in the intensity of record rainfall, and then there's a local recipe for disaster due to poor maintenance of dams, not designed for this amount of rainfall. The presence of dams created a false sense of security, leading to the expansion of a city in a flood-prone area with a loss of experience, and the consequences of conflict and war in Libya completely prevented early responses. So we try to provide at least the physical part and a description of the unfolding of high impact events in that way, which can also help to better understand the health dimensions, for instance, of extreme events in specific contexts. The upper one, which I have highlighted here, the second one, is one of the first attributions to the weather conditions leading to out-of-control wildfires in Canada last summer. And what is particularly striking are the amount of CO2 emissions from these wildfires in Canada, more than 500 million tons of CO2 in one season, so more in one season than several years of emissions from all the Canadian population. And this illustrates the importance of ecosystems, where climate change can affect their state, lead to degradation, damage air quality in the US or Canada due to the effects of wildfires on atmospheric composition locally. So at the global scale, what we see is an intensification of impacts and related losses and damages attributed to climate change, affecting water availability for around 3 billion people, affecting agricultural production with losses, in particular due to drought, extreme heat or flooding, effects on livestock health and productivity, multiple effects on health and well-being. So I've added vector-borne diseases, which you are familiar with, due to shifting potential climatic zones. But in terms of health, what is really striking is the direct effect of heat on morbidity, mortality, capacity to work, the effect of displacement due to flooding or fires on mental health with post-trauma long-lasting effects, a dimension of mental health linked to the degradation of the environment, a feature called solastalgia or environmental grief, and also the eco-anxiety, which is associated with the perception of a gap between the action that should be taken and the action actually implemented. We also see, of course, effects on cities and infrastructures, in particular associated with flooding. In the tropics, we observe a higher proportion of the most intense tropical cyclones, no more frequent, but a larger proportion of category 4 and 5 cyclones. And when they hit a city, these are the events that lead to the longest lasting economic damages affecting economical growth several years after the events. Effects can be direct on human societies, but also mediated through the consequences for biodiversity and ecosystems. Half of the studied species are shifting over land and the ocean. We see mass mortality, typically in France. The mortality of trees has increased strongly in the last decade compared to previously. The growth of forest has been slowed, with the effect in particular of drought. And this has led in France the expansion of forests, which absorbed around 7% of greenhouse gas emissions, a natural sink, to be almost divided by 4, only absorbing around 4% of annual emissions. And this illustrates the consequences not just on biodiversity ecosystem functions, but also their services, such as storing carbon and limiting the effect of our emissions. So I think from the situation we are now, we provide the understanding of 33 climatic impact drivers, how they are changing in every world region, what is attributed to human-caused climate change, and how these factors will change as a function of the level of global warming. And therefore, we can project many of the impacts which are related to these climatic impact factors as a function of future global warming levels. Our assessment remains too limited at the moment in terms of what affects mostly biodiversity. In particular, there are dimensions related to climate velocity, which should be further investigated, and they are more relevant for biological processes. So I think there are research directions to be developed jointly between our communities in the future. So this is for today, and very clearly the extent of to which today's and future generations will be exposed to a hotter and different world depends on choices now and in the near term. So let's look at, depending on different choices, what are the possible futures. So I showed you the outreach version, and now let's look at the hard scientific information underpinning this simplified version. The most important thing to remember is that what will determine future warming are cumulative CO2 emissions, which are related to the burning of coal, oil, gas, and deforestation. So, if you would like to limit warming at any level, the rules from geophysics give you a margin of action, a remaining carbon budget associated with any global surface temperature goal. What we also know now is that if we reach net zero CO2 emissions from human activities, we do not expect more warming in the pipeline. The inertia does not come from the climate system. It comes from the inertia of our infrastructures, our economic choices, our investments, in particular that lock in fossil fuel use in the future. So we can look at different scenarios that have different trajectories for CO2 emissions at the global scale. Very high, intermediate, low, or very low emissions. And you can see, as expected from the former relationship, that as long as global CO2 emissions do not reach zero, you still have a drift of global climate and continued warming. So it's the case for all the yellow and red scenarios. The yellow one is the one closest to current policies that would lead us to around 3 degrees warming by 2100 at the global scale, which means over most land areas, around 4 degrees of warming. Warming is amplified over land compared to the ocean surface. If you would like to stabilize warming by the second half of this century, we have to reduce sharply CO2 emissions, and then when we reach net zero, we reach the peak of warming driven by CO2. If we would like to go back a bit after reaching a certain level, then it's conditional to the ability to eliminate CO2 already emitted in the atmosphere and store it on the long term, a feature which is associated with questions about feasibility, costs, and additional risks, depending on the methods. Of course, emissions of short-lived compounds that affect both air quality and climate also have an effect, but it's secondary compared to CO2 emissions on the long term. And of course, future climate will not look like a smooth history. It will be modulated by natural variability, and therefore we will encounter sometimes earlier, when you have the most extreme conditions of today's climate, what will be mean conditions in the future. For instance, in France, the hottest year encountered so far was year 2022, multiple heat waves, severe drought, wildfires in many regions. That would be the mean climatic conditions by 2050 in an intermediate scenario in France. So thinking of 2050, we need to think of what will be the worst case situations and be prepared for that to ensure the resilience of our societies. I'm a paleoclimatologist, so I could not resist showing that into context. So what you see here in the upper panel are estimates of past changes in atmospheric CO2 concentration over millions of years in the past, and reconstructions of past changes in the Earth's surface temperature. What is really at stake is the following. We are already out of the range of temperature of the warmest period of the current interglacial period, looking at the last decade. Depending on future emissions, we can be completely out of the range of the warmest period of the last million of years. So for me, what really matters is the velocity of changes, because it's the slow pace of glacial interglacial variations that has shaped the responses, the adaptative capacities of the ecosystems we have now. So thinking carefully of our legacy means, do we want to act now and limit warming to a range that has already been encountered in the past million years, or go really fast out of that, with many unknowns, in particular about biological adaptation and their implications? So depending on the level of global warming, what we can say is that it will affect mean climate in every region, it will affect extremes, and it will affect in a disproportionate way the rarest extreme events. So we have to expect an increase in the temperature of the hottest days, That's why, for instance, in a city like Paris, we need to prepare for what happens when the temperature reaches for the first time 50 degrees and be prepared to ensure access to key infrastructure, health, having functional laboratories, for instance. And that calls to anticipate and be able to do climate stress tests now to ensure the resilience in the future. The second dimension here is the change in annual soil moisture, and all the regions in gray, orange, brown are regions that will be subject to aridification in a warming climate, meaning a gradual decrease in soil moisture. And this will exacerbate the pressures on the use of water resources, in particular because it will increase the demand for irrigation. You can see the whole Mediterranean area, South Africa, many regions in Asia, Australia, the Great Plains, Central America, and the Amazon region being particularly concerned. And even in the drying regions, we expect an increase in the intensity of the most extreme rainfall events. So we need to prepare for a more intense water cycle and a more variable water cycle with more wet and dry seasons and events as a function of the level of global warming. There have been a couple of studies about the implications for ecosystems. This is one example of a modeling study focused on around 30,000 species. Not much microbes here. It's mostly, birds, reptiles, amphibians, fishes, and mammals. And what you can see is, as a function of the level of global warming, a higher percentage of species can be exposed to a risk of loss, first in the tropics, in particular with coral reefs, for instance, and endemic species. So the take-home message is, if you would like to keep biological diversity, in addition to local pressures, which are the first driver of degradation, limiting global warming is critical to avoid increasing pressures and increasing the risks of losing species. And this implies thinking conservation, protection, and restoration of ecosystems so that it can help species to move, so that they can adjust to the shifts of their climate zones. When we look at the land and ocean ecosystems, we see that as a function of the level of global warming, the severity of risks, which goes from undetectable in white to moderate and severe in yellow and purple, clearly increases. And this concerns, for instance, permafrost degradation. For each degree of global warming, we expect to lose about 25% of the frozen soils over 3 meters. There can be implications for frozen life in these areas that requires to be anticipated and studied, and which matters, in fact, for how many greenhouse gases will be released, in particular the unknown, mostly related to the emissions of methane. I mention here carbon loss to illustrate the risks of losing services and functions from ecosystems under pressure in a warming climate. In the tropics, we have already lost potential of sustainable fish catch due to a warming climate. So the effects of increased temperature on marine life also matter in terms of food and nutrition security. What I would like to highlight is that with less snow in the mountains, less glaciers, it means less water resources available in the dry seasons coming from the highlands. With a faster changing climate, the pressure on ecosystem will close some options which are now available, such as nature-based solutions, greening cities, restoring wetlands, which can be adaptation strategies now, but can be threatened in the future if the pace of climate change cannot be coped by the adaptive capacities of the species and these ecosystems. Thinking of climate and health, one core aspect are associated with human physiology limits. So they are illustrated here by conditions in terms of extreme heat and humidity, which pose a direct threat for life in the case of physical outdoor exercise. It already occurs several days per year in many regions. And you can see that as a function of the level of warming, the spread geographically, the intensity and the number of days increases with further warming. This also will mean a loss of capacity to work outdoors, which can have social and economic implications. It will also mean an increased demand of cooling to just be able to recover at night, a further challenge to reduce emissions in a warming climate. Looking at the food system is currently unsustainable. A third of global greenhouse gas emissions, pressure on ecosystems, issues associated with water resources and quality, and 800 million people suffering from being underfed or poor nutrition, and 2 billion people suffering from chronic diseases due to excess calories and unsustainable, too heavy diets in a way. So what we see that in a warming climate and with 2 more billion people to feed, we will see major challenges, in particular because some of the yields of key cereals, such as maize, have an optimum and then a decrease for today's cultivated species after 35 degrees. So this is projected in the purple areas. And we expect the decrease in the fish catch potential in the tropics to increase with further warming. The green area around the Arctic is associated with a large uncertainty due to complete shifts in ecosystems related to not just warming, but also the loss of sea ice, species moving. It's already an area of increased tensions from international fisheries expecting to occupy the areas available with a decrease of sea ice. So when you look at both health or food security, what is really striking is that, of course, the risks increase with the level of warming, but they strongly depend on the choices that will be made, and in particular with investments in the health system, with adaptation of working places and cities, there's a possibility to reduce the severity of heat-related morbidity and mortality. In terms of food insecurity, it strongly depends on the type of development. For instance, supporting poor farmers, enhancing their incomes, increasing their adaptation capacities is key, together with preserving land for food production, and shifts in diets, because the type of diets, and in particular animal-based proteins versus plant-based proteins, is a strong pressure on the use of land, which can exacerbate or limit, depending on the choices, the effect of a warming climate. This is one example of some of the most difficult and complex risks that are increasingly observed. The same extreme heat and dry event affects soil moisture and food production locally, leading to an increase in local food prices. And at the same time, due to the effect on the ability to work outdoors, a reduced household income due to reduced labor capacity, and these two drivers increase or reduce food security, with the risk of increased malnutrition and effects on health and well-being, in particular at the most fragile ages, such as pregnant women and young children. So if there's no action at scale that is being implemented now, the risk is to increase the conditions that can lead to poverty traps and threaten the ability to develop and reduce extreme poverty. Last point, in terms of futures we would not like to live, is associated with sea level rise. So sea level has increased by 20 centimeters since 1900. Whatever trajectories of greenhouse gas emissions, we expect it to rise by another 20 centimeters by 2050. By the end of the century and later on, you can see a factor of 2 between very low or very high emissions, so very low warming, very high warming. And with a dashed line, we have illustrated one of the possibility for a high impact outcome that would be the triggering of instabilities in ice sheet processes that can lead to a destabilization of part, for instance, of the Antarctic central ice sheet, flowing faster into the ocean. So this dashed line is important because we don't know the temperature threshold under which such outcomes could materialize. We know that cities on the coast want this type of information. Those who invest in critical infrastructure on the sea want to have that critical information of a worst plausible case, so that to take it into account for decision making. And you can see in that case with the dashed line, we cannot rule out 1.5 meters sea level rise by the end of the century and multi-meters in the next ones. This matters because what are the consequences of sea level rise? Chronic high tide flooding now, this decade, more recurrent extreme sea level events during, storms of the century in the future, erosion of sandy coasts, salinization of water resources, as already seen in some areas already. So aspects that can threaten local security of habitats, the habitability of coastal zones, and access to freshwater resources as well. And the challenge is that most responses take time to fund, design, implement, and they are also associated with limits. For instance, ecosystem-based adaptation by restoring mangroves, for instance, or sediment-based protection will not work in the case of a fast pace of sea level rise. All hard infrastructures have hard limits, and they can give a false sense of security, leading to more assets being next to these infrastructures, and if their capacities are overcome, larger losses and damages. So one key aspect is being able to plan the relocation of coastal infrastructures further inland, where they will not be affected on the long term by the consequences of sea level rise, and this concerns about 1 billion people altogether. You can find in our report a summary of the key climatic impact drivers, key risks and adaptation responses per region, per sector. This is just to highlight, for instance, in Africa, key risks associated with food production, ecosystems, heat and infectious disease-related mortality and morbidity, and the effects of sea level rise. Africa being one of the regions where we already see a reduced economical growth and food production due to the consequences of climate change. If we look at Europe and small islands, we can see that there are 4 main risks identified: extreme heat for health and ecosystems, losses in crop production that can affect the global food markets as well, water scarcity, which is not just drought, but also the lack of water in rivers that affect economic activity, for instance, around the Rhine River recently, affecting about 1% of the GDP of Germany. And the last type of risk is associated, of course, with the multiple aspects of flooding. And thinking of small islands, the understanding of the risks are much more closely related between ecosystem health, resources, and implications for societies that depend on these ecosystems, for instance, coral reefs and fisheries, or tourism, or coastal protection. In small islands, there's not much water storage, and extreme droughts, such as in Mayotte now, leads to more acute water crises that affect everything, including, of course, basic health, with issues of cultural heritage, habitability, and the ability to address, through solidarity mechanisms, losses and damages in more fragile economies or countries. So we see that we will have to adapt. We will have to change scale in adaptation. But it's not sufficient to limit the escalation of costs and risks. Reducing climate-related risks really calls to reduce greenhouse gas emissions much faster than planned currently in pledges from all countries. So I go back to this CO2 temperature relationship. to stress how you can make sense of remaining carbon budgets. The margin of action to limit global warming to 1.5 degrees Celsius, when we update it, is very limited, the equivalent of 7 years of global CO2 emissions at today's level. It means if it does not reduce after 7 years, we'll reach that level of warming. The margin of action that limits global warming to 2 degrees, you can see it with the second green bar, is about equal to the emissions expected from current and planned fossil fuel infrastructure. How to translate that? New investments in fossil fuel exploration and consumption are not consistent with the Paris Agreement. It also means that if these infrastructures are implemented, they will need to be either retrofitted or stopped before the planned term. It's also a high risk of financial losses and stranded assets. So it really matters, this aspect, and this is at the heart of the tense discussions taking place now at COP28. And whatever the terminology will come out, phasing out fossil fuels, phasing down fossil fuels or unabated fossil fuels, what really matters is the ability to reduce their use as fast as possible, grounded in scientific evidence. I want to highlight where we are. You can see the little gray zone in the upper corner. These were the outcome of governments' pledges before the Paris Agreement in 2015 that would imply an increase in global greenhouse gas emissions by 2030. We are now at the red part. So you see that with the current efforts put on the table by all governments, we could have a peak and a small decline in global greenhouse gas emissions if this is implemented by 2030. And let's look at what would be needed to be serious with limiting warming well below 2 degrees, the trajectory in green, or to limit warming close to 1.5 degrees Celsius in blue. What would be needed is a decline by about a quarter by 2030 to stay well below 2 degrees, and a decline by about a factor of 2 to stay close to 1.5 degrees Celsius. Remember, different greenhouse gases have different characteristics. So for CO2, we need to reach net zero. For short-lived climate gases, greenhouse gases like methane, we need to decrease them, but not to reach net zero. So there are different implications for different types of greenhouse gases. And the good news is when we look at the solutions available, we have a technical potential from what is available now to divide by 2 global greenhouse gas emissions. 3 main categories of actions: technological innovation, demand, sufficiency and efficiency, and nature-based solutions. So for each system, for instance, the energy system, you can see the size of the bar is the potential to reduce emissions, and the color of the bar is an estimation of the cost. So it requires a ramp-up of investment to be able to avoid emissions. That's clear. But from an economical perspective, the gains that could be achieved by avoiding health costs of air pollution are equivalent to the amount of investments to decarbonize the economy. So I really try to frame climate action as something that could be a well-designed public health policy. So a shift towards all the sources of low-carbon heat and electricity that are designed to be resilient in a warmer climate. For land, water, and food, you can see aspects related to ecosystem and ecosystem health, aspects related to efficiency of agricultural practices, and aspects related to the demand part. So this is an example of the terminology that was acceptable for countries. Initially, it was written plant-based food, but for meat exporters, it was not an acceptable language, and it had to be modified to shift to sustainable and healthy diets. But it means when you eat too much sources of animal proteins, much less of that, and a higher proportion of vegetable proteins. So it's one aspect where recommendations for nutritious and healthy diets align with diets that reduce their environmental footprint and therefore can have benefits for public health, together with a specific attention to ecosystem health. So systemic changes, energy, food system, water, and managing land. The other systems are cities, which include city design, as well as transport and building. And you can see there's no single silver bullet. You have to play on all options, including city design, nature in cities, in particular for having cooling islands with parks and vegetation, as well as working on the efficiency of buildings and transport. And aspects associated with health benefits include better winter and summer thermal comfort, improved in air quality, less noise in cities, as well as active mobilities such as cycling and walking. And you can see there's a special emphasis on the responses of health systems as a core ingredient in this decade of resilience and decarbonization, together with multiple aspects of solidarity, including climate services, early warning systems, and social safety nets expanded to adaptation to a warming climate. So you can see that from these multiple examples, a health dimension is extremely strongly present in what can be the benefits of a well-designed, when implemented, strategy to reduce greenhouse gas emissions. At the scale of individual choices or professional choices, what really matters are strategies and infrastructures that make low-carbon lifestyles accessible. And it can be usually summarized in what you avoid, such as long-distance flights, what you shift, for instance, your diets or your mobility choices, and what you improve, such as the retrofitting of building, low-carbon heating, or performant electric vehicles. And this aspect is really critical because the demand side, sufficiency, efficiency, low-carbon lifestyles, is around 40 to 70% of the global greenhouse gas emission reduction potential by 2050. You cannot achieve that by playing on technology alone. You need to have a change in values, practices towards these low-carbon lifestyles, including in professional contexts, which are part of just transition processes. To finish, I want to highlight that thinking of climate action is not just a matter of climate action. It has to be grounded in all the dimensions of sustainable development. So each option, and we can look at that in our case for the energy, in urban industry transitions, each choice can have co-benefits and trade-offs with other dimensions of sustainability. If you increase the tax on fossil fuels, you hit the poorest hardest. And this challenges the first sustainable development goal, which is to eradicate extreme poverty, as an example. So thinking very carefully of the profiles of different options, and in particular the health benefits, can help in each context design and implement well-informed choices that benefit both limiting global warming and societal choices in each context. So with rapid action, what I stress is that we can shift choices. With the technical potential to divide by 2 greenhouse gas emissions, we have the choice of shifting towards sustainability. But it has to be done quickly because each missed opportunity means more warming, more losses and damages, more consequences. Another challenge is the ability to have this long-term vision of transformations together with the way to address the other types of shocks and crises. The effect of the pandemic, build back better or support the economic sectors very intensive in fossil fuels, and choices have been different in different world regions. At the moment, conflict and war. What will be the outcomes? Expenses in defense globally reach $2,000 billion per year in the world. Will it help to transition to low-carbon economies, or will it block it and delay it? In current conflict areas between Russia and Ukraine, between Israel and Palestine. Water is being used and water infrastructures as a weapon in the conflict. This will increase the vulnerability to a changing climate. So thinking very carefully of how to put an emphasis on sustainability and have a long-term vision that can be sustained despite all other crises to manage is really critical. So just going again to the graduates. You train by science. Knowledge plays a key role here. I'm personally convinced that knowledge and sharing knowledge can empower people to understand and to take action. One aspect is climate literacy, understanding the causes, the consequences, and what we can do. I tried here to share with you, these aspects which are critical for climate literacy. And I hope that you can also be ambassadors of transformations towards sustainability, and in your professional choices, be actors of these transformations. Thank you very much.